In this lesson on exponents, we're going to have a look at exponential equations. When the variable that we want to solve is in the exponent, we talk about exponential equations. Then our aim is to get only one base number on each side of the equation and for these to be the same. Most of the time, we do this by changing the base numbers to prime numbers. Let's have a look at A. In A, we have two base numbers on the left. So we are going to start off by getting rid of the 5 by dividing by 5 on both sides. So then we'll have 2 to the power of x is 8. In my next step, I want these two base numbers to be the same. And that I will do by changing the 8 to 2 to the power of 3. Now that the base numbers are the same, we can make the conclusion that the exponent on the left has to be the same as the exponent on the right, so x is 3. In example B, every single base number has an exponent, and this means we cannot get rid of one of the numbers by dividing by it. So we're going to start off by changing all of the base numbers to prime numbers. So 9 will become 3 squared, 27 will become 3 cubed, and the last one is already a prime number. Now I'm going to use my exponential laws to simplify. So it's going to become 3 to the power of 2x minus 2 equals 3 to the power of 3x times 3 to the power of x plus 2. And now to get only one base on the right, I'm going to use my law that says if the base values are the same, I can simply add my exponent. So that will give me 4x plus 2. Now, once again, my base numbers are the same, so I can make the conclusion that the exponent on the left is the same as the exponent on the right. And now I will have 4x minus 2x is 2x, and minus 2 minus another 2 is minus 4. If I now divide by 2, I will have x as minus 2. Just like in exponential expressions, as soon as there's more than one term, so as soon as there are pluses and minuses, we have to start off by factorizing so that we have one term on each side of the equation. So let's have a look at an example like that. In example 2, we now have two terms on the left of the equation. That means we will have to factorize. Now, to determine what type of factorization we're going to use, we have a look at the coefficients of the variables in the exponent. In example 2, we will see that both the coefficients of those variables are 1. And if the coefficients of the variables are the same, we will use common factor. I'm going to start by expanding the first term on the left into 2 to the power of x times 2 to the power of 2. And now I have two terms on the left. And in these two terms, 2 to the power of x is my common factor. So I'll be left with 2 to the power of 2 minus 1. There's never nothing left because you are dividing, and anything divided by itself is 1. So now I can simplify. So I have 4 minus 1, which can then be simplified again to get 3. And if I have a look at this now, it's similar to example A, where both the 3 and the 12 do not have exponents. That means I can get rid of the 3 by dividing on the right. Now I can change the base on the right to prime numbers, and then I can say that the exponent on the left is equal to the exponent on the right. You can also get coefficients in the exponent where the one coefficient is double the other one. And when that happens, you will use trinomial factorization. So let's look at an example like that. In example 3, we once again have more than one term on the left, so we will have to factorize. If we have a look at the coefficients of these variables, we have 2 and 1, which means the one is double the other, and then we'll use trinomial factorization. So I'm very quickly going to remind you that 3 to the power of 2x is the same as 3 to the power of x times 2, which we can write as 3 to the power of x to the power of 2. I'm going to start off by rewriting the first term as 3 to the power of x to the power of 2. And then I'm going to expand the second term to give each exponent their own base. If you look carefully, you will see that 3 to the power of x appears more than once. So we're going to use the k method and say, let 3 to the power of x be equal to k to simplify this for us. So when I substitute, I'm going to have k to the power of 2 minus 4 times k times 3 is equal to 27. And now I have a trinomial. I have k squared minus 12k minus 27 is equal to 0. And now I have a quadratic equation, so I'm going to either factorize or use the formula. So I will factorize it like this. And then I have two options. K is either 9 or k is 3. And now I just need to substitute back the k with 3 to the power of x. So 3 to the power of x is either 9, which is 3 squared, or 3 to the power of x is equal to 3, or 3 to the power of 1. And then I have x can be 2, or x is equal to 1.